Okay, video 2, just another lot of questions from a student. They look like they're Enrollo ones. If you feel like having a go at some, just feel free to pause and have a go before I do them too. So we've got the So Good stall, runs a series of demonstration sessions. In each session, 3 types of skills, applique, binding, and cut work are demonstrated. 600 people sign up for the sessions. Can't say that word. The participants change their choice from session to session according to the transition matrix T below. Okay, P1 is the state matrix for session 1, showing the number of participants in each type of demonstration. Okay, of the participants who chose applique in session 1, what percentage are expected to choose cut work in session 2? Okay, so applique in session 1 we have, that is the 300 here. But what we need to work out is the number of people who do cut work in session 2. Okay, so how we're going to do that, we're going to do the transition matrix times P1 here. Okay, and we only really care about the cut work part, but if you want, just scan ahead. I'll quickly do that. Just know as well, if we only really care about cut work, we could just do this here. So we're looking at cut work for the next one. So in terms of A, we've got 300 times the 0.3 plus B has 200 times the 0.2, so I'm just doing that value there, plus C, which has the 100 times, that's a bad times 0.1. Okay, so just if you didn't want to do the transition matrix, same thing, because we only care about the cut work part, so I'll just do that there, 0.3 plus 200 times 0.2 plus 100 times 0.1. It's probably better to do the transition matrix only because then you could just see if you made a mistake, because I got 140 for that. But you can just see with the other values, you can just make sure it adds to the 600 total. But we'll back the instincts here. We've got 140 for cut work. Okay, so to answer the questions, of the participants who chose applique in session 1, what percentage are expected to choose cut work in session 2? So we've got our applique part here. That's that 300. Okay, so they're going to contribute 30% towards this total of the 140. So it's essentially asking, like, of our 140 that are doing cut work too, what percentage came from the applique part? Okay, so to do that, 300 times. Okay, so that equals 64.29%. Cool. All right, of the participants who chose cut work in session 1, how many were not expected to choose cut work in session 2? Okay, so we've got cut work in session 2, that's that 140 here. Okay, and we've got the cut work in session 1, that's the 100 there. Okay, so of the participants who chose cut work in session 1, how many were not expected to choose cut work in session 2? Okay, so that would be the... So this 60 and 30%, they're the ones who are not choosing cut work. So I'll choose cut work in session 1. I always have to reread this question. Session 1. How many were not expected to choose cut work in session 2? Yeah, so I think the part that's tricking me on this one was asking for the percentage, and this just wants how many were not expected to choose the cut work. So we've got 100 here, and we can see that the 60 and the 30% that won't choose it means that 90 people won't choose cut work. Okay, so just doing that 100 times 0.6 plus the 100 times 0.3. I think the question was getting me as just like, I didn't read this. I was thinking about percentages. But yeah, 90 won't choose cut work in session 2. Okay, so Hayley will interview one international fashion model every day of the week from Monday to Friday. Okay, so on Monday, Hayley's going to interview Regan. And then we're going to use the permutation matrix to choose the model to be interviewed each of the next 4 days. Okay, the order in which Hayley will interview the remaining 4 models for the next 4 days. Okay, so if on day 1, Hayley chose Regan, what you do then is you go Regan today. Who's going to be the next one? You just go down to where it matches the 1. So that will go from Regan today to, is it Leon? Okay, then down from Leon to N, down from N to J, and then down from J, that's here, down from J to P. Okay, so that will be C. Cool. All right, next question. 3 crop sprays are manufactured by combining chemicals A, B, and C as follows. Okay, spray P contains that. Spray Q contains that. And then spray R contains that. To control a certain crop disease, the farmer requires 6 units of chemical A, 10 units of chemical B, and 6 units of chemical C. How much of each type of spray should the farmer use? Okay, without doing just trial and error, this is just a simultaneous equation. So you could set it up as a simultaneous equation if you wanted. But we'll do it via matrix method. So I'm going to have a 3 by 3. And what I'm going to have is spray Q. Sorry, that's P. Spray P, spray Q, and spray R. Okay, and then in the rows, I'm just going to have the amount of chemicals in each. So chemicals for A, B, and C. Okay, I'll just fill that in. So P was 1, 3, 4, Q, 3 of each. And then R, 2, 5 units of B, and 0 of C. Cool, and then essentially we want this to equal 6 units of A, 10 of B, and then 6 units of C. Okay, so you could do it trial and error, but I would just do it as simultaneous equations. So it's going to be that times how much of X, Y, and Z will get us to that. Okay, so then I would just have X, Y, Z. Oops, it's Y. That's a terrible bracket. Equals the inverse. I'll just say it's my transition matrix, or T, or doesn't matter what you label it as. 6, 10, 6. Okay, I'll just find that. I'll see if we can... Oh, maybe not. I was going to say, see if we do it just now. Have a go on our heads. I don't think it'll be nice numbers. Only because of Q. Q's all threes. I don't think... Yeah, I don't think we can get to this. It'll be decimals, so... 3 by 1. 6, 10. Okay. How much of each type of spray should the farmer use? So I've got the answer. I'll just write it up here. It doesn't say how many decimal places. So I'm just going to use 2. But yeah, the question would be nice if the question said. But so I've got they should use 0.65. That's not it. 0.62 of A. 1.18 rounded for B. That's both A and B rounded. And 0.92 also rounded for C. Okay, and then it'll just be making that statement. Therefore, 0.62 how much of each spray? So 0.62 of P. I'll just write it of P. 1.18 of Q and 0.92 of what's next? R. Cool. All right, next question. So we've got a tournament. Everyone plays each other once. There's a winner and loser. So we've got the one-step dominances and the two-step dominances, which makes the total dominance. Okay, which is the sum of the one-step and the two-step, which is shown here. Okay. I haven't done the question, but just know if you ever have to work out total dominance via matrix methods, yeah, you'll add the one-step, add the two-step, and then you'll get this total dominance matrix. But the total dominant player is essentially if you add the rows, and whoever has the most will be the best player. So if you wanted to add the rows, we need a column matrix. Okay, so 1, 1, 1, 1. Okay, which would get us the most dominant player. But in this case, I'll just put here, might not need it, but okay, so it looks like J and K. Oh, I can't add. Sorry, K has 4 wins. 5, 4, 2, 3. Okay. I'm just talking about the twos. Sweet. Okay, so we get some information. So Team J defeated Team K and Team L defeated Team M. Which one of the following is the correct one-step dominance for the tournament? Okay, if you wanted to be lazy, what you could do is you could just square each of these, because it's a multi-choice question. And there's nothing wrong with doing this, in my mind. Square each of these, then do the original plus the squared, and just see which one gets you to this total dominance. You could do it like that. But we'll try and have a go at making the one-step dominance. So I've got my one-step. All right, no one can beat themselves. Okay, J, K, L, M. do that. Okay, and then we know that J bet K, and L bet M. Okay. Cool. All right, so just so remember the wins are always the rows, the columns are the losses. All right. What are we up to? Okay, so down the column, down the diagonal, it's going to be symmetrical, or not symmetrical, but where there's a 1, opposite side will be a 0, so our M lost to L. Okay, and then K lost to J. Sweet, and then we're sort of left with this. Like I was saying, I think in the other video, it's going to be easiest to focus on L. So L had 2 one-step and 2-step wins. So if L, if we have the other win for L against J, J just has a lot of wins up in here in total. So what I might do is I'll make, this is very trial and error, but I'm going to make the 2-step dominance matrix. So we know that down the diagonal is all zeros because the diagonal of the total dominance is all zeros. Okay, and then what I'm going to do is I'm sort of just going to work backwards from this 2-step dominance one to start filling in as much of this as I can. So we've got this 1 here, L bet M, and in the total dominance, we've only got a win there. So I'm just going to have this as a 0. That means this has to be a 1 because of this 1 up here. What else can we do? All right, these 1s here. That one's going to be a 0 because we've got the 1 in the 1, J bet K in the 1-step dominance. Okay, that means it has to be a 1 there. Okay, now that's sort of, we've filled in as much as we can. So I'm going to look back at L. So L has the 2 wins overall. And that 1 win comes against J. But I think if I do that directly, I'm going to have too many wins for L. So L beats M directly here. So we're going to look at who M is going to beat. I might say that M beats J directly because then that's where that other win for L comes from. So which means that's going to be 0 there. And if M bet J, that means J lost to M, which means this here's going to be a 2. All right, let's look at M. M beats J. You can tell this just it's very trial and error this way, but M beats. L defeated M. M against K. Okay. So the other one we're going to look at is this value here. So one of them has to be a 1 because M has 3 wins. I'm just going to make sure I don't put it in the wrong spot though. So I'm just going to say, okay, so if M beats K, what's the flow on effect? If M beats K. K has no win so far in my one step. J. All right. I'm going to do this. So J has 5 wins overall. At the moment, J only has 1 win against K. I'm going to say that J beats Al as well because she's the most dominant player, he or she. Yeah, she's going to have at least 2 wins. So that's going to be a 1 there. Means that's a 1, but J beats L. And you guys are probably going to be quicker at this than me, but J beats L, which means L lost to J. Okay. So where are we at now? Who's the other one? Al and K. K has to be... this has to be a 1 here. Just looking at K and L. So looking at this spot. I could just wing it and say K beats L because K has more wins. Which is probably not the right way to do it, but I'll see if it works. It had to be like that anyway because we already had the 2 wins for Al. Okay, like as in the 2 1-step and 2, like the 1-step one and the 2-step one. Okay. M. Alright, then we need the M and K is the last one. K has 2 wins so far. Okay, so K has to beat M because M has 1 win so far against J, and J beats 2. Like J beats these 2 people, K and L. That's the 3 wins for M. So that means that's our 1-step dominance matrix. Okay, bit of fiddling around. If anyone knows a better way, please tell me than that. As I said, whether you think it's easy for your time, it's probably like you could just square each of it. It's probably easier that way. But if it wasn't a multi-choice question, I get like you're gonna have to do it this way. But yeah, like you get there. It just takes a bit of time and a bit of fiddling around. And even if you make one little mistake, like just change it, go back. But yeah, if anyone finds out like a really nice way, please let me know. That'd be great. So cool. All right. Hopefully that helped. Oh, I had it in the video. I realized I probably should finish off this 2-step one just to make sure it works. So what I'll do is just make sure this all works. So if we look at, I'm just going to look at M here. M needs 3, I'll just write these again. So 3 wins for M, 2 wins for L. 4, why did I do 5 again? 4 for K, 5 for J. So I'm just going to go across each person. I'll start at J. Like if I add this row and this row, that adds to 5. So J's good. K has the 2 wins in the 1-step. And the 1 win there. And needs another win. I might fill K in after. L has 2 wins. L's all good. Add those up. M, there has to be a 1 there because M has 3 wins. And then to K, I'll just add it up. So K beats L. And L beats M. So I'm just looking at the one step. So K beat L. And L beat M. So that means that's a win for K. Where's M? Here. Okay, and I think that's our all our wins for K, because there's our 2 and 2 there. Cool. All right, again, if anyone knows a better way, please let me know. That'd be great.